If we come back to the minimum variance portfolio, here you can see in the wiki the actual derivation of this. There is a second question, so I'm just going to come back to the minimum variance in a second and first handle the question from Nicolas. Transaction cost calculated on the entire portfolio every time, or only the percentage that has changed? So just let me just emphasize slightly more. This part of the transaction cost, TC, transaction cost, is applied to the amount that is traded. Okay, so if you have 10% in TY at date T, and then at date T plus 1, you want to have 20%, then your actual change is 10%. So your trading is going to be equivalent to 10% of TY. So this here, this 1 basis point, is only going to apply on the allocation change to the trade, the size that you need to move your allocation between the 2 days. However, this here is a flat penalty. So whether you change 10%, 20%, 30%, 2%, doesn't impact the fact that each time you're going to pay 2 basis points to rebalance that. That's really the trick. So this is, as it's flat, it's impacting the number of rebalancement. This will have a higher cost if you are moving larger amounts. It's slightly two different dimensions, as I said before. Thank you for that. I hope that makes it clear. Let's go back to the minimum variance and see. So here, if you want to read into the math, what's happening, you can read this page here. Basically, what it does is it's choosing a rolling period backwards in order to assess what the variance covariance matrix of the underlying assets. Here, our underlying assets are TY, US high yield, and bank. Was over this rolling period. Here we've defined a rolling period of roughly 1 year in terms of business days. So it's going to roll 1 year each time. And on this 1 year, we're going to assess what the correlation or covariance was between the 3 assets. And then we are going to allocate in an inverse proportion to this variance or covariance between the assets. So this is really what the minimum variance is doing. It's also a pretty simple approach, but it's proved quite efficient across time. So we have already run this. Obviously, we've piped it with minimum rebalancing frequency. This should be run every time because it is possible that the rebalancing that are being computed by this minimum VaR portfolio payout might not be optimal in the number of rebalancing that we're doing. So if we pipe these two, we are somewhat making sure that not only we have this behavior, but also we have optimized the number of rebalancings on this behavior. So now we can run the backtest, and we will see what we get. Here we go. So we have, remember before we had -13 drawdown, now we have only -8. So we are getting a slightly better downward behavior. However, we have lost a bit on our annualized return, but the Sharpe ratio, so the adjusted return for risk is better. It's above 1 now. Here we have a behavior, and what we can see from this graph is that basically what we concluded here in the static weight portfolio by comparing it to the equal weight portfolio, saying this looks like it's behaving slightly more sporadically or with more volatility than this one, and this one was favoring fixed income. The min VaR portfolio is telling us exactly the same story. Banks here, they have very little allocation through time, and the 2 fixed income assets have been favored. So this means that banks have more volatility versus the two other ones. So we have slightly better behavior from this payout, slightly lower returns though, but also a better protection against downside. This function is what defines the logic. How do we make sure that we allocate to proportionally, basically, to the variance, and how we compose the portfolio with the minimum variance across all possibilities. So that's just a quadratic optimization problem. We can look into the payout here, which I've just copied in the script, but you can find it in QLib, in the QLib. The QLib, again, just as a reminder, it's here, and this looks like this. And here I have my mean var weight. So you can, on the left, you have where you can find it. And here you can see the definition of the function. So there is a code here, and you can go and directly copy this code if you need it and put it in your Alphien Studio. So this is what I've done. I just copied the code, and then you can see. Let me just get that bigger. There we go. We can read how the function works. So basically, it's telling me that it's taking a matrix of returns. Let me emphasize something here for you. We are always dealing with time series, and in our time series, they are better handled and easy to manipulate through what's called XDS. Okay, and XDS here is a helper package in order to manage time series. And each time we ask you to give us a matrix of returns, basically we want the XDS format. You can read about XDS in the documentation here, but it helps a lot to manipulate easily time series. It's important to check what format is expected when we use premade functions. There is another argument, rolling period. So it's telling me that it's 252, okay, on the US calendar. This is the number of business days in a year. So it's going to roll every year, and then it's going to rebalance daily. Okay, so that's the default behavior. The allocations that it will generate will also be daily. So we might want to skip the few lines at the beginning, but this is really to make sure that all the inputs here are correct. So this is not impacting a lot the behavior. Let's go directly to the core of the function, which is here. And here, what we're doing basically is using a roll apply. So when I explain how it works, this minimum variance portfolio is going to assess the variance covariance of the three assets over the rolling period, here 1 year. And each time it is going to compute the matrix, and then it will deduce what the combination is to obtain the minimum variance for the portfolio. So we need to do that basically 252 times times the number of day of the backtest, and roll this period forward, in order to be able to generate everyday allocations. So an efficient way to do that, here again we're using a premade function which is called roll apply, and this is an efficient way rather than doing a loop yourself, where you could basically do for I in and then the number of days of the backtest minus obviously this rolling period. You can directly use roll apply. Roll apply, all these package functions are already optimized in terms of coding, in terms of execution time. So it's always better to favor these than to write your own loop if you don't need explicitly to do something different. So we're using roll apply, and what do we say to roll apply? We said the matrix of returns, I will need to roll over 252 and apply the function which I define here. So this function will be applied in a rolling fashion, so just like a for loop, across the backtest period, which is represented in rows in returns. And the function here is just as I said, the real core of the computation. So we're not going to go into every line, but it's the quadratic optimization just to invert the matrix and get the optimal weight to get the minimum variance portfolio. So what is the combination of weights across these three line assets that is giving me the portfolio with the lowest variance across the period? And so it's going to do that all across the backtesting period. And then so this is rows 58 to 70. This will generate my allocations across the whole backtest. If you want to go into more detail, this optimized mean var is where the quadratic optimization is happening. It's using quadratic programming packages, solvers. SolveQP is the solver that is being used, so you can have access to that on the platform through all the packages. Here you can QuadProg is the one that is being used here, and so if you want to include that in your script, you can just need to tick it and use this line in your script, just as an example. So if you want to go into more detail here, you can read it in the script. You can go to the QLib, check every line. You can also go to the wiki, which I have referenced, and see exactly what the theory behind the portfolio is, and you can dig a bit more if you are interested in that. That is all available to you. What's important is to understand the structure of this payout and understand how we have constructed to make it the most efficient possible. And as I said, just a tip, each time we are manipulating time series, we use XTS. That's one of the basics. There's no need to use data structures that are not appropriate for the manipulation you want to do. So if you are working with time series, try to use as much as you can XTS. Sometimes it's not going to work if you do quadratic optimization, but that's just a matter of one or two operations. Then you should move back to XTS in order to make it efficient. Few remarks. We have a lot of functions that are already available on the platform that we use here. We use return for E, and this function returns. It computes annual returns from a return series. So that you feed in daily returns, it's going to give you an annual return, just like here, this sort of format. We are using roll apply, which is an efficient way to apply a function, like a transformation, across a rolling period. This is what it says. We are also using cbind to combine XTS, as we said, the data structure for time series, so that the dates are well aligned. It's very important to make sure that dates and index are very correctly aligned in time. It's very easy to make a mistake there. It's very easy to have a problem when it comes to joining different time series that have slightly different dates. So please use functions that make it easy to do so. Otherwise, in the stress test, you might have a forward-looking bias, which is something that some of you have already experienced, and then it's quite difficult to see where the mistake was made, and often it's because some time series were not joined properly. And lastly, we use also NA log F, which is basically replacing NAs in a forward-filling manner. I see there is a question for a rolling period. So I'm not sure what performance means, but the rolling period basically, you can have as large a rolling period as you want. However, your data set is limited, as we've seen here. As we've seen here, the data set we have spans from roughly 2010 to 2019. So the more you use a rolling period, the more you're losing, in a sense, results on your backtest. However, the more you are increasing the rolling period, theoretically, the more stable your assessment of the variance covariance matrix is. So there is a trade-off here. So you need to basically make a decision here. Yeah. Can I roll for every week? Yes, you can roll for every week. However, this rolling period is a period, so it's a number of periods. It's slightly different from frequency. So you can change frequency here to weekly. Okay. If you change it to weekly, you just change the input. You can change the input here. So we see 1, 2, 3. The rebalancing frequency here is daily. Here in your portfolio, you just add weekly. Okay. However, you have a problem because here it's going to roll over 250 weeks. So you're losing a lot of data. So if you wanted to roll only for 1 year, for example, this is the equivalent of having variance covariance being computed only on weekly points over 1 year. Okay, so this is maybe the distinction that you wanted to know, Young, is that this is the number of periods and this is the frequency. So as far as we use weekly, the data is transformed to weekly, and then you have 52 points in a weekly frequency in order to cover 1 year. So you can play around with this. I encourage you to look at the documentation of this function as we showed here. There are also here a lot of examples that you can directly copy and run in your RStudio. You'll see there are many different combinations where the frequency is changed to weekly, for example, here, and then you can also change the allocation frequency. So how much allocation the function is going to generate, how many allocations functions you have. Right. So thanks, Kiam, for the question. That's good. So I invite you to, as I said, just read the documentation, play around, make some tests with different sets of parameters here. You can always add parameters to the payout. It goes at the end. Okay, so here this parameter can change to monthly, and you can, if you want, generate allocations also here monthly rather than daily. You need anyway this frequency to be above the rebalancing frequency, but this will generate allocations only on a monthly basis. So that this is about the output, what your function is going to output. This is about the input. So this is pretty much how this function is used. As I said, all information is available. If you don't find what you need, just ping us a chat or send us a forum message, or just ask the community on the forum. Other people can also answer, and that will help make things clearer.